my dear student, I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of the surface of the properties of matter as we observe here for our subtopic of the surface tension. Today, we are going to proceed with our discussion here on the determination of pressure difference of a liquid. But before we start discussing here, we are supposed to remember what we learned on the last session. On the last session, we tried to see how can we determine the formula of the surface tension using the capillary tube. We tried to demonstrate, and finally we finished it by saying that the surface tension always, my dear student, is obtained by taking the R times the density times the G times the G bracket. Then we take H. Then we take H. We add it by R over 3. We divide it by the 2 cosine theta, and we tried to simplify more. And after there, we obtain that if the tube is very, very narrow, we should identify the surface tension by taking the density RGH, then we divide it by the 2 cosine theta. That is what we identified after assuming that the tube is very, very narrow. It is very narrow. Then the R over 3 is assumed to be negligible on our formula. So now today, let us see how can we identify the pressure, how can we determine the pressure difference of the liquid. So as we seen here, my lovely student, we observe that the pressure difference for the liquid lies in a narrow in a capillary tube can be described using the figure number 13 for our topic number 6 as we seen. That we describe this pressure difference for the liquid in a capillary narrow tube using the figure number 13 for our topic number 6 that we are going to demonstrate for our next slide here. So when the capillary tube is placed in water as shown in figure number 6.13 as we observe Roman A. Initially, the water level is in the same inside. Is the same inside and also at the outside tube. We should go and observe our figure number 6.13 on Roman A. We are going to try to observe that, my dear students, that initially the water level is the same. It means that the water level that are found in the capillary tube is the same with the water level that are found outside of that capillary tube, as we see in here, my dear students. But the concave meniscus indicate that the pressure at MPN, kwamba huyo concave meniscus should indicate that the pressure at a point M, ambayo tutamuita ni pressure at pressure M. It means hapa kulikuwepo na M, ni typing error. This there is the M as we seen here, my lovely student. Kwa kwenye point M sasa, ambao ndo kutatusaidia kuweza kuidentify the concave meniscus ambayo ina indicate the pressure ambao tunailabel kwa leta ya PM. Tutasema kwamba hii pressure ni ndogo kilinganisha na pressure ambayo itakuwepo kwenye pointi ya kwenye pointi N. Kwa yule pressure ambayo yupo kwenye point M ni very, very small compared with the pressure that is found at the point N ambayo tunaita ni PN, pressure respect to N. So my lovely student, let us proceed with our discussion as we seen here that hence water in the tube will rise to the height H. as shown in our figure number 6.17b. This also figure number 13, number 13 for our topic number 6 here, tried to explain the rising of the water in the tube at the center in height. Kwa kama tunavyoona sasa, hii ni figure ambayo inaelezea kuhusu the capillary action, how the capillarity works, how the amount of water rise and fall in a narrow tube. That is what we see on our figure. We have the three figures, my dear student. We have Roman A and also Roman B, finally also the Roman C. On Roman A here, we observe that the water is the same inside of the tube and also outside of the tube. The amount of water is the same. But here at the figure Roman B here, we observe that the amount of water is not the same. Inside the tube here, amount of water lies at the center height. Lies at the center in height, my dear student. And after rising, they form the concave meniscus, as we see here. They tried to form the concave meniscus. Also, the figure Roman C here, as we see, my dear student, indicate that this indicate the amount of the liquid. Tunaona kabisa kwamba the amount of liquid that is formed at the center theta. Kama tunavyojaribu ku observe, it is formed at the center theta. This enables us to identify the angle of contact. Kama tunavyoona, this is the angle of contact which is formed between the surface of the liquid and also the surface of the solid here, my lovely students. The R represent the internal radius of the tube. Kwa ile ni internal radius of the tube. Kwa tukijaribu kudissolve, tutajaribu kuobserve pale. The angle theta here, my dear student, angle of contact must be the same with the angle that is formed at the center between the small letter r and also the capital letter r, as we seen here. Kwa yule angle wa hapa ni sawa na angle wa hapa kama tunavyojaribu kumobserve. But according with our statement, my dear student, say that at point M, the pressure is very, very small compared with the pressure that are found at the point N here, my dear student. And also, if we compare, we see that also this pressure N here, this pressure M is less than also with the pressure that are found at the point A. Kwa huyu pressure M ni mdogo kuliko pressure aliyepo kwenye point N. Na huyu pressure aliyepo pia huyu wa M atakuwa ni mdogo kuliko yule atmospheric pressure. Yule pressure ambao anabini into the tube. Atmospheric pressure wetu yule. Kwa hiyo ndo concept ambao tunajaribu kuinoti kwenye hizi demonstration zetu, my dear students. Now, how can we get the excess pressure? On the past lecture, we tried to explain the way we can obtain the excess pressure. And we said that when we talk about the excess pressure, this is the difference between the pressure, which is obtained by taking either P1 minus P2 or by taking P2 minus P1, which is equal to 4 times the surface tension divided by R. This is the formula that we demonstrated on the last session. Now, for here, if we consider the first figure here, we should say that, my dear student, the excess pressure is obtained by taking the pressure at the point N we minus by the pressure at the point M. Kwa nini tunasema hivyo? Kwa sababu tulisema kwamba ule pressure ambayo yupo kwenye point M ni mdogo kulinganisha na pressure ambaye yupo kwenye point N. Kwa hiyo sasa tutachukua ili tuweze kupata excess pressure, we should take the pressure at the point N we minus by the pressure at the point M, which is equal to the excess pressure ambayo ni 2 times the surface tension divided by R, as we seen here. So since the height of the liquid is h and it is density is this one. But we know that the height of the liquid, my dear student, is obtained by the letter H as we seen here, ambayo tuna represent kwa kutumia letter H, na pia yule density anabii ni represented kwa kutumia huyu density huyu hii symbol yetu hapa kama tunavyojaribu kuobserve. Now we should say that the pressure at point M, yule pressure ambayo ata exert kwenye point M hapa atakuwa ni sawasawa na pressure aliyeko kwenye point A we minus by the density times the GH. Kwa hapa tunaongelea kwenye figure on Roman B here, my dear students. Now the pressure at point M must be equal to the atmospheric pressure we minus by the H times the density times the acceleration due to gravity. Now, my dear student, let us end here. We should proceed with the next session here, my lovely students.